In this image, we can see a ferrite and pure light. The darker regions are pure light and the lighter one are ferrite. Here now we are going to calculate the percentage of ferrite and pure light using this software. Now I am clicking the measurements and phase. Click new phase. Now I am assigning a color to the darker region and enter the name as pure light. Click auto and the darker regions will be in red color. Next add, click add, new phase. Here the software calculated the percentage of pure light, which is 63.74. Now we are going to calculate for ferrite. Click new phase. Now assigning a different color. Click OK and enter the name as ferrite. Click auto. Now the ferrite regions are in blue color. Click add. We can get the percentage of ferrite, which is 36.26%. If you want a report, click summary report and enter the details here. Click report. The report will be generated in Excel file. This shows a image before analysis and this is after analysis. The percentage of ferrite and pure light will be calculated and the graph is also created for that. Also we can get the data like number of fields calculated and magnification, area of the image, and what is the calibration, that is 1 pixel equal to how much micron, and units. These data are date and the specimen name. These data are automatically generated in the report. In this microstructure, we can see a retained austenite which is in white color, and this is captured at 1000x. So I am giving a magnification as 1000x. Now we are going to calculate the percentage of retained austenite in this microstructure using this software. Using the same phase analysis, we are going to calculate the percentage. Click new phase and I am assuming a color for it. Click OK. Since the RA is in white color, we have to click light and we have to enter the name as RA. Click auto. The phases will be detected in blue color and click add. The software will calculate the percentage of retained austenite, which is 2.64. And to generate a report, click summary report and click report. The report will be generated in Excel file and the same image, which is the first one is before image analysis and the second image is the after analysis, and the amount of percentage of retained austenite will be, the data will be there, and the same will be generated in the graph also. Now we are going to do coating analysis. For that I have selected the image. Now we are going to measure the coating thickness, and this image is captured in 100x. So I have given a magnification as 100, and we are going to, the black region is a mold and the white region is the coating layer, and this is the surface of the material. Now we are going to do the coating measurement, coating thickness measurement. Click coating thickness, and since the coating is in horizontal direction, we have to click a horizontal and click auto method. Click add layer. The color will be detected there. Since our interest will be in white region, we have to move this threshold. Our area will be in blue color, and this is And if we click on the image, we will get a boundary layer, and we have to give mask interval as 25 so that it will generate a lines on the image. Then the software will calculate the thickness of the coating layer. This is the minimum thickness, maximum thickness, and the average thickness. Then to generate a report, click report. We have to enter the details here. The report will be generated in Excel file, and this first one is the before analysis and this is after analysis, and the calculated values will be here. Now I am going to explain how to measure the grain size. This is a single phase boundary and captured at 100x magnification, and I am given the magnification as 100x. Now click grain size. I click set threshold and linear intercept. Give a maximum number of lines as 10. Find grain size. Click find grain size, and automatically it will be calculated the grain size, and now it is 5. After clicking the find grain size, the 10 lines will be generated on the image, and the grain intercepts will be calculated on each and every line. And we have done a calibration. With the use of that, the total line length will be calculated, and using the grain size formula, by using the grain size formula of grain intercept and total line length, the grain size is calculated, which is 5. Inside the grain boundaries, there are some artigraphs which is also calculated as a grain intercept, so that using that the grain size is calculated. To avoid this, we have to create a template. Now you will see how to create a template using this software. To create a template, we have to select the image and then click process, build macro, click a grayscale, and I am executing that step, and then click sharpen image and executing it. Depends upon my need, I am clicking the threshold normal and executing it. And click thin image. And I am executed this. Click clean up thin image and enter the value as 35 or anything as per your need. And some of the articles will be removed. There will be some gap in between the grain boundaries. The inside spots will be removed by clicking the remove inside spot, executing the step. And to fill the grain gaps, I am clicking the fill grain gaps, and then click white grain on original image and execute it. We will get the template in that image. Click add sets to configuration. Click the enter the configuration name as grain size. Click save, and data has been successfully created. I have created a template. Using that, we are going to see how to calculate the grain size. Now we will see the result. I am taking the image grain 1 to 3 where we have created a template. Click run. The template has been opened. Click linear intercept and give as many as lines as 10. And after clicking the find grain size, the number of lines will be generated on the image, and the grain intercept will be calculated, and from the calibration the total line length is also measured. Using the formula, the grain size is calculated as 3.5. In the initial image we have got as 5, but now we are getting 3.5. We have seen in a linear intercept, if you want a circular intercept, we are having two methods. One is Hillard and another one is Abraham. If we click Hillard, the single circle will be generated, and click find grain size. The grain size will be calculated here. And in Abraham's, we will get 3 circles, and clicking on the 5 grain size, we will get the grain size value. If we do not have a formation of the grain boundary, we can draw it manually. Click grain size and click draw grain, and I am drawing on the grain boundary. This is a bigger one. The grain size is calculated, and if you click add grain and draw on a smaller grain boundary, and again click add grain. This will give an average grain size as a 3. Now we are going to do inclusion analysis. For inclusion analysis, we have to prepare the sample carefully. The surface must be free from the scratches, pits and other polishing defects. So it will be easy for the software to differentiate the inclusions. Now we will see how to do the inclusion analysis. Now I am going to click the image and inclusion. Click find inclusion, and we have to move the threshold to select inclusions alone. Now all the inclusions have been selected and it has been filled with color. And if we drag the mouse point to that, it will show the width and the length of the inclusion. Here it is mentioned as 11 and length as 82 micron. And if you see, and the result will be there. It will give whether it is thin series or thick series. Here it is a type A and thick series. If we have type B, type C and type T, the result will be generated here. Click add, and to generate a report, click report. Automatically the report will be generated in Excel file, and this shows before analysis and after analysis, and the rating will be mentioned in the table.